Okay, so I'm going to go over the review sheet that you guys got yesterday. So I'm going to go through the answers and just write them in. And then you can either be writing these in as well if you printed it, or typing it in if that's easier for you. But this will be a great tool for you to use to review for your test. So the first one is math. Some of these may look familiar because these were on another review sheet that you've had before. So I've used some of the same questions because the test will have some of those questions from your quiz as well. So mass is the amount of matter contained in an object. Measures the amount of space a substance takes up is volume. Defining matter, that is anything that takes up space and has mass. That's like the formal definition. You could say also everything around us. You could put that in your own words, but that's the formal definition. Anything that has mass and takes up space. So below, you're just deciding if it's a solid, liquid, or gas based on the description. So the first one has a definite shape. So that should be a key thing there to tell you that that's a solid, because solids all have a definite shape. No definite shape is going to be either a gas or a liquid. But when you see that it says that the atoms move somewhat, or the molecules move somewhat, that's going to be your liquid. And then the key word here is freely. If they move freely, that's going to be your gas, because they can move basically infinitely or indefinitely, like oxygen in the air. It's all around us. You can't see it, but it's all around us moving around. These properties can be observed without chemically changing matter. So without chemically changing, and it's a property, is going to be physical. And then these properties are going to describe how a substance interacts with other substances, and a new substance is formed. So key thing there, new substance is formed. That's chemical properties. All right, the next one you're just labeling if it's a physical or chemical property. So just a reminder, this has been a little bit since we've done these. So remember that physical properties are not going to change what the substance is, where a chemical property is going to change it. You can't get that chemical back, or you can't get that item back if you have a chemical property that you're observing. So hardness is just how hard it is, so that's physical. The ability to react, so like if I mix baking soda and vinegar, that's a reaction, so that's chemical. Luster is the shininess, that's physical. Toxicity, so if it's toxic, it's chemical. The appearance is your physical. Flammability, like when I lit the paper on fire, that's chemical. And then melting and boiling points, that's just when your solid turns to a liquid, or your liquid turns to a gas, like in boiling. That's all just changing the state, so it's just still physical. Number 10, changing the state of matter, or a phase change. So like I said, like a solid, ice, melting, to water would be a physical change, because you're not changing what it is. It's still the same thing. It's still water. It's just gone from a solid to a liquid. Now the changes. So this is going to be, again, same idea. Physical is going to just change the look, and then chemical is going to change completely what it is. So you cannot get the item back once a chemical change takes place. So burning paper is obviously chemical. Baking cookies, remember when you bake things, chemical reactions are taking place, so that's chemical. Dissolving salt or sugar in water is physical, because you could get those back if you boiled it. Ice melting, physical. Burning wood is chemical. Boiling water, still water, it's just changing states, physical. And then crushing a can is still physical, just changing the look of it. Okay, all right, so next page is going to be getting into the newer information that we did here. So number 12, these are made up of only one atom. They cannot be broken down, and they're identified by their physical and chemical properties. They're on a big table, organized on that. That's going to be an element. Okay. When you take two or more elements and you combine them together, that's going to form a compound. So an element example, I'll just give you like oxygen, nitrogen, carbon. So some examples of a compound would be like CO2, when you take carbon and oxygen and combine them. If you take hydrogen and oxygen, you make water. So those are compounds. Those single elements are up here. Okay. When you mix two or more substances together, you're making what? It's a mixture. And now we're going to get into the two types of mixtures. So which of the following are examples of a heterogeneous mixture? Remember that hetero means different, meaning you can pull the pieces out, you can see the different parts. So you're just going to say yes or no if it's a heterogeneous mixture. So oil and water, I did this example. Can you see the two different parts? Yes, you can. Sugar and water? No, because it dissolves. Trail mix? Yes, because you can pull out the parts that you like. A salad? Yes. If you don't like certain things on a salad, you can pull them off. And then cement is not a heterogeneous mixture because it's a bunch of items put together, but it all looks like one thing. Okay. And then an example of a homogeneous mixture. Homo means same, so it's going to be like uniform. Looks like all one substance. So oil and water, so it's a no because it was a heterogeneous mixture. Sugar and water, it's a yes because it dissolves and it looks like it's just water. Remember I said that if you put like salt or sugar in someone's water and mix it in, they won't be able to see it, but they'll be able to taste it. So that's a homogeneous mixture. It looks like water, but there's stuff in it. Trail mix is a no because you can pull the pieces out. Salad is a no because again, it's heterogeneous, you can pull the pieces out. And then cement is a yes because you have multiple things in it. It just looks like one item. So 17, the periodic table is organized or is an organized table that displays what? It's displaying elements, all of the elements. There's over 115 discovered at this point. So this is what the tiles look like, or the squares look like on the periodic table. This looks like a rectangle, but they're squares if you actually look at the table. So we're going to label the different parts. So the first number up here at the top is going to be how it's organized. So they have the numbers organized, so they go in order of how many protons they are. They have, but that number up in the corner is called your atomic number, and that's how they organize it. That letter C is going to be your symbol. The word carbon down here, that's going to be your element name. And then down at the bottom is going to be your atomic mass. Okay. Almost done here. These last couple are multiple choice, and then there's a few that I just listed the specifics so you can have it. So how are elements arranged in the periodic table? We just talked about this. It's organized by that number up at the top. So it's organized by the atomic number, starting with 1, which is hydrogen. 24, the periodic table is split into 3 main sections, and it's split into metals, nonmetals, and metalloids. And then I go into just giving you the details about each one. So metals like gold, that's an example. There's mostly metals that you'll find on the periodic table. Most of them are metals. They're malleable, meaning you can move them, you can bend them, you can shape them, typically by heating them. They're great conductors of electricity, of heat. They can be shiny, typically hard. Properties of nonmetals. So an example of a nonmetal would be oxygen. So it's a gas. Those are poor conductors. They're brittle. When they are a solid, they're brittle. They can break easily. They're not malleable and they're not shiny. And then, metalloids. So silicon is an example. So that's going to look like metals, but they act like nonmetals. So they're not great conductors, they're not malleable, but they can be shiny and lustrous, but also brittle. But there's only, if you look at the periodic table, there's like the step that goes down. That's all going to be separating those metalloids out, so you can see them. All right, 28, the starting materials for a chemical equation, or what will be reacting, also going to be on your left side of the equation, are your reactants. And then the ending materials of a chemical equation, or the new substance after the reaction's taken place, also known as the right side of the equation, is going to be your products. And then the last one here, I am not going to have you balance an equation on the test. I'll have it as a bonus question, but all I'm going to be asking you is basically to identify how many atoms there are of certain elements in an equation. So looking at this equation, again, I have my reactants on the left, my products on the right. I'm going to go ahead and label these things for you. The little number, remember, is your subscript. The letters are your element name or your element symbols. There are no coefficients on this. So there's no big numbers in the front, so there's no coefficients. But the subscripts are going to tell you how many there are of each element. So we have oxygen on the right side, and we have a little 2. So we have 2 atoms of oxygen, and then 4 atoms of nitrogen. Then over here, the little 6, so we have 6. And in 2, we have 2. So the other thing I might ask is this equation balanced? So here's your equation. You have 2 oxygen, 6 oxygen. So that's not balanced. And you have 4 and 2. So is this equation balanced? No. No, it is not balanced. And then for the extra credit on the test, I'll give you an opportunity to balance an equation. And if you get it right, then you get a point. If you do not get it right, it will not hurt you. Okay. So if you have any questions about this, let me know. You also have the Kahoot to play that will also give you some review questions and help you with that as well.